Okay, we'll go ahead and get started. Thanks everyone for joining. This is going to be our session on how to choose the right ERP option for your project manufacturing business. My name is Deborah White, and I'm going to be conducting the presentation today. First, if we look at agenda, we're going to go through a couple introductions. We're going to take a look at some of the things that you really need to look at when you're making decisions about what you should use for your manufacturing and your ERP practice. These are going to go through anything from project requirements, design and engineering requirements, production, compliance, all the way through to giving your customer the best customer satisfaction that you can. This session is being hosted by Kinetic. Kinetic is a Dell Tech GovCon partner and an IBM Premier Business partner. We specialize in anything from design, deployment, testing, implementing, support services for all of Dell Tech's products, including time and expense, and Cognos, BI, and TMI. We have been in business for quite a few years now. I recently joined in 2017. Again, my name is Deborah White. I've got pretty extensive experience working with government contractors in a project manufacturing or engineer-to-order environment. Pretty much my very first job a long time ago was a cost accountant for a government contractor. So I pretty much spent my entire career on these subjects. Now we're going to ask ourselves, I think, an internal look of how do you view manufacturing at your company? Do you consider yourself a small business or a large business? Who are your customers? Do we have commercial customers? Are our customers the government or government departments? Or is it a mixture of both? Also, from a manufacturing perspective, what's your manufacturing mix? Do you do discrete or repetitive type manufacturing where you're building multiples of the same item? Do you have a mixture of engineer to order where you're actually designing or taking somebody's design as a sub and building it for them? Do you have a lot of research and development? Or are you a mixture of all three? Any of these things kind of fit our view manufacturing as a project-oriented basis. And then my final question, do you consider yourself a project engineer-to-order manufacturer? Now, if we take a look at this at one step farther, what is project engineer-to-order manufacturing? Do we have detailed project reporting requirements? Are you interested in looking at your financials by project? Do you need to report to your customer at a project level? Are you going to be audited at a project level? Then the next piece is, do you consider yourself to be engineer to order? Now, you can be engineer to order and still be a discrete manufacturer. You can repetitively build something you've designed, or it could be more R&D or high level, just depending on what the nature of your business is. Project manufacturers tend to build very complex products, and you can see by the picture here, you know, you've got some very complex products. A complex product could be night vision goggles. It doesn't have to be a large item to be a complex item. It's really the amount of design that goes into it and the complexity of the manufacturing for it. Also, do you manage based on detailed customer specifications? So again, looking at this is on an engineer-to-order basis, a lot of your requirements are coming directly from your customer, and you're trying to make your customer happy so you can continue to work with them for new business and continue with the business you have. And then the last is, do you have that layer of industry and government compliance? Most companies will have industry compliance. You've got accounting standards. You've got cost accounting standards. But when you're a government contractor, it also adds another layer of compliance on top of it. Do you have to adhere to the FAR? Do you need materials management accounting standards? If you answer yes to one or more of these questions, there's a good chance you are a project engineer to order manufacturing company. Now we're going to look at project requirements to kind of drill into this a little bit more. And again, as you're looking for an ERP system, you want to make sure that it covers the areas we're going to be talking about today. From a specific project requirements, first, what type of projects do we have? Cost reimbursable, CPFF, time and materials. Do we have fixed price? Do you have to adhere to Revenue 606 or ACS 606 standards for your fixed price? So that's one area that we need to take a look and make sure we can cover. The next piece is we have to look at how are these projects funded. Many times you can have a top-level project where each task is funded separately, especially for cost reimbursable projects. It could be at the top level, it could be by task. The more tasks we have will affect our project setup because we have to track at that task level, and that will also affect how you do your inventory tracking and how you manufacture. So for those of you on the phone that are government contractors, you know that it's not as easy being a manufacturer for the government as it is to be a commercial manufacturer because you do have these particular stipulations you have to follow. Other stipulations we want to look at are earned value management requirements. Sometimes these can affect how our projects are set up. In turn, how the project is set up will influence how we have to track our materials and our inventory. Next question is, do you plan by project? Commercial manufacturers, they have the luxury of planning across many different things at a given time, where if we're a government contractor or we by project, which means those parts may be segregated by project, they're ordered by project, and the costs are flowing through to that project. So these particular considerations have to be taken into effect if you are manufacturing by project. And last but not least, and I kind of mentioned it above a little bit, is compliancy requirements. Depending on the type of projects you have, you may have particular compliance requirements that you have to have and prove that you follow within your system. Now, when we look at inventory itself, and the inventory, again, is normally governed by how the project has been negotiated or and where it's funded at, but you can have different kinds of inventory as a project manufacturer. You can have straight asset inventory or otherwise known as common stock. This is items that are typically held on your balance sheet. It is your company's inventory, and you can issue or use that material on any project that you need to. Okay? So it's definitely, when you're looking at it, it has a lot more flexibility than some of the others because it's not project owned, it's owned by your company. The next is work in process inventory. And work in process inventory usually falls for fixed price type projects where you want to buy the material for the project, you want to plan for that project, but at the same time, you can't recognize all of the revenue or all of the costs up front. You're either doing this as an estimate to complete to meet the 606 revenue standards. In that case, this inventory, you have flexibility. You could set it up as asset inventory and reclass as cost of goods sold based on an estimate to complete or other method, or you can expense this inventory and at the end of each period, reclass it back to the balance sheet what you've not been able to recognize revenue or cost for yet. So a couple options with regard to that. For those of you who have cost-plus projects, the third example here is very near and dear to heart. Normally, for a cost-plus or cost-reimbursable type project, the inventory is technically owned by the project just as soon as you buy it, because you're going to turn around in that period and you're going to invoice your customer for any costs that you've incurred. This inventory is still inventory. You're still responsible for tracking what you have, what location it's in, how much, and technically how much it cost, even though those costs have already been expensed. This inventory is owned, again, by the project, and it must be treated as such. And there's a lot more tighter rules that especially the government will give you on how you have to handle this material. And the last type of inventory that you could have is government or customer furnished material. The government refers to it as GFM. This material is given to you, and they've inquired it on other contracts, or they have this material, and they're giving this for you to use in your manufacturing process. Again, you're still required to track it, know how much you have. You're still required to track a value for it. But again, there's no general ledger impact for this material because it's really not yours. It is your customers. They own it. You did not buy it for them. They gave it to you to use. So these, again, are different considerations being in a project environment and especially in a government contracting environment. Now, other things that you're going to look for in inventory is the ability to have multiple warehouses. Can we do serial lot or UID tracking? A complete audit history. Do you know when these items came in, when they were issued out, who they went to? These are all things that you have to consider part of a kind of a standard inventory package that would have. The next two are a little bit different. Soft or hard inventory allocations. Sometimes you buy a part that is machined with a right side and a left side. In these cases, you may want that right side and left side to always be issued together. So you could hard inventory allocate particular serial numbers of parts so they're used together. The last one we have here is product or part technology security. This is related to anything that is on the United States munitions list, the EAR or the EAR 99, which is considered protective property by the United States. These items, you're not really allowed to let non-U.S. citizens see the bill of materials, see the routings, see the manufacturing orders or how these are made. So that's another consideration, that if you are ITAR restricted, this part technology security becomes very important for you. The next thing we want to look at is going to be our design and engineering changes. Now, naturally, the big thing we always worry about is, did we design the right product? Is our product going to meet our customers' requirements? Is our bill of materials accurate? Pretty much industry standard wants you to have a 98% accurate bill of materials. That's really nice and a really nice thing to strive for, but because of the nature of industry we're in, we have lots of engineering changes. These engineering changes affect our bill of materials on a weekly basis. Our customer changes their requirements. Our engineers find out that their original design works better if we swap out these parts for other parts. There's all kinds of reasons why we may have a lot of engineering changes. And how we handle these can directly affect our bottom line. And I apologize, I skipped over one here. And our routings. Do we need standard routings? How do we make the parts? These could be anything from a kitting to a machining to a QC inspection step that we want the folks that work on the floor to follow to ensure our product quality. And then finally, what kind of documentation do we need to provide to our customer at the end of the process? So we're going to provide the item, but we may have to provide part traceability, including serial numbers, lot numbers used in what was being manufactured. We may have to provide an engineering BOM versus a manufacturing BOM. There's a wide variety of things project that you're required to give the customer along with the item you're delivering for them. Now we look at the bill of materials. So very first question here is how we design the part. Is that how we actually make the part? And a lot of times you're going to find that when we look at a bill of material, we're given from our engineers an engineering bill of material. That is how they have designed this part. But you've got to ask yourself some questions here. Does it include all the components? Can it be flattened to shorten manufacturing cycle times? So those questions can kind of lead up to one of the next bill of materials. So we have an engineering bill of materials, whether it is in your ERP or it is in your PLM, pretty much everyone in our business is going to have an engineering BOM. The next piece, though, we have is the manufacturing BOM. And the key thing here is the E-BOM is how we've designed the item. The M-BOM is how we're going to manufacture the item. Okay, and these can be different just depending on your requirements. Now, the M-BOM is going to have things in it like component types. Is it a quantity per each one you make? Is it an as-required part like solder or epoxy or something like that? It's also going to have what's called effectivity dates in it. When did that part become effective in the bill of material? And if the engineer swaps that part out, when did the ending effectivity hit for that part and a new part takes its place? So these are all things we look for in a bill of materials. The other item we may look for is phantom parts. So one of the questions previously on the screen here was, can we flatten the bond? Normally, engineers will make a bill of material for every subassembly in that bill of material. Sometimes those subassemblies are very small, take little effort to do, so we do have an option of flattening them and building them in a higher level if we want. So again, when you're looking at how something's designed versus how you manufacture it, these things might be a little bit different. The next thing is if you do have a PLM system, whether you're using Windchill, AutoCAD, Visio, whatever we're using to do our drawings in, we may want an option to be able to push into Costpoint or your ERP package any of the part information or bill of material information that is collected in your PLM system. So that's another thing, whether it's with preprocessors, whether it's a web service interface, these are all things we look at to try to streamline our process. The sooner we can get in our hands the manufacturing BOM, the sooner we can actually start producing the item. And the very last type of bill of material that you might want to use is the proposal bill of material. The proposal bill of material takes historical data from your E-BOM, your M-BOM, maybe existing work orders, and helps you come up with new bill of materials to possibly use in your bid and proposal process. Routings, which we touched on lightly, routings are how we make the item. So normally you have your bill of material with the components. The routings are going to be the steps. Again, do we kit the item? Do we machine the item? Is there a QC step? So we look for in these routings different things like what work center an employee might be working on. We are also going to look for different types of operations. Again, kitting, machining, QC are all different type of operations. But what happens if you have to send a part outside to have it coded for you? You need chromate. You need a water jet procedure where the item is cut or polished in some manner. These are called outside processing steps or subcontractor steps. They also add to the cost of manufacturing and are a direct cost of the item you're producing. Another thing we might look for is an operationalized bill of materials, where your bill of material is identified to the routing steps to which the part should be delivered. This operational bill, if you're making something large like a secured vehicle of some sort or a boat or something like that, you may want parts delivered at a particular time when they're needed in the routing process. The next, efficiency standards. This is extremely relevant if you're doing repetitive manufacturing, where you can come up with how long it should take someone to do a particular piece of the routing step. You can then compare that to actuals, and you can see, do you have some technicians who are struggling with a particular step that may need some additional training or help understanding how to do that particular step in the process. And the last piece is, if you're using a manufacturing execution software in addition to your ERP, do you have integration between these two systems? In which case, normally a manufacturing execution software would contain the routers. It would be the owner of the routers or work plans, and it would feed that back to your ERP system. And the last, one of the most important things with the engineering and design phase is the engineering change notice. And again, these are produced by the engineers as they wish to make changes to the bill of material or the router. Now, normally these have a pretty extensive approval process, notifications to the impacted groups, and one of the very important things is it has an impact report. This impact report should show you, if you're going to swap out a part number in a BOM, it should show you visibility into any open purchase orders, requisitions, manufacturing orders, or inventory that you have for that particular item. If that item is an expensive part, it could certainly help you by having this view into it prior to approving that engineering change notice to be able to see, can we rework what we already have? Does it really need to be scrapped, or can we use it as is? So it's going to help you manage your project overruns because, again, especially in an engineer-to-order environment, you've got long lead time items, you're designing them and having other vendors or suppliers deliver them to you. You need to know what is out there, what's been ordered, so that you can have visibility into how will this ECN affect my bottom line. The next thing we're going to take a look at is going to be our planning and production, materials planning and production obstacles. And there's several of these. First thing, do you have enough parts to meet demand? I think that's every manufacturer's concern is, do we have the right parts? Do you need to plan by project? Netting group, is there a way to group projects together where they can share parts? Can your project use common stock? Other considerations are going to be your long lead times. So with a long lead time item, again, if there's engineering change notices, it's going to cause us a problem. Other things, my supplier can't deliver. Supplier is backlogged. They don't have time to deliver it for you. They can't get the part. Then the next question is, when are my parts coming? Do you have good due dates? Do you have good lead times that you can order the parts in enough time to get them in when the demand calls out for them? Another question, can I borrow from another project? Now this one is one that's actually a compliance issue. You may have other projects in-house that have that part, but you have to go through approvals to be able to use their part, and you have to pay it back to them without harming their project. So basically it means that you cannot charge them more than you borrowed the original item at. You have to pay it back at the same cost that you borrowed it from. And then finally, is there a viable substitution? Is there another part that could be substituted for this item? The bill of materials calls out a 3/4 inch flathead screw. You have a 1-inch flathead screw that is the same dimensions, just a little bit longer. Can you use that? So these are all kind of questions that come along. And probably one of the biggest questions is, do you have the resources to meet the delivery expectations? And resources are anything from people, machinery, CNC machines, any type of resource that's necessary for manufacturing. Now, when you look at this, you want to look for something that has some planning features. Again, having the right parts at the right time. You may want to look at a MRP, or Materials Requirements Planning System. With Materials Requirements Planning, you do have to have accurate inventory and accurate bill of materials. It helps if you have valid lead times, because MRP looks at the due date and backs into when all the parts have to be entered. If you have any scrap or yield factors, if there's a particular part that you have that for the every 10th one you touch, it breaks. It's a delicate part. So you have to order overages. And then the last question is, do you have viable substitutions for any of your parts already in stock? You have to actually be ready to proactively react to schedule change. And this kind of comes down to the fundamentals. You don't want to be reactionary all the time. You don't want to be somebody running down the hall with their hair on fire saying, I don't have the part, I need to get the part right away. You want to try to be as proactive as possible in your business. You also want something that is going to accurately match your supply with demand. When you look at supply is going to include things like what you've currently got on hand, what you currently have on order, what you have approved to order, less what's already reserved for other orders. And that basically is where your supply is coming from. Your demand is going to look at your things like customer sales orders or inventory reservations, where you have demand to build a particular item, and you want this to be able to match all of the parts that are required for that item to the current supplies that you have. And again, the ability to plan by project, project task, or a netting group. Finally, again, where demand is coming from, and I kind of already went over this, but you could have a master production schedule where you could put in how many of the items you want to produce on a weekly basis or monthly basis, inventory reservations, and sales order demand. Now, other things you want MRP to be able to do for you is give you different kinds of messages to act upon. A planned order is basically a new order. It's going to tell you any new orders that you have coming in or any new demand you have coming in, what supply you need to order to meet that demand. Reschedule messages, cancel orders, these two kind of go hand in hand. With these two, if your customer's due dates change, you have a problem on the floor that the CNC machine is broken and you need to move out a due date on a manufacturing order, anything like that could trigger reschedule messages or cancel orders. Your customer cancels, you're going to have to cancel the purchase orders if you can. Transfer suggestions, this is really more going back to multiple projects and being able to borrow from those projects. A transfer suggestion is just that. It basically identifies that another part may be available, but again, you have to go through the proper means to actually transfer that part to your project to be able to use it. Next, we have substitute part planning. or do you have any parts that can be substituted? The next one's kind of interesting, but it is GFM planned orders. Do you need to kick off an order to your customer that you'd like for them to send more of the parts that they are supplying? And then again, the last one, pending ECNs. You want MRP to point out for you if you have any pending ECNs out there that you need to take into consideration. The next thing we go into is the master production scheduling. With master production scheduling, this is not an option for everybody. This option primarily, if you have repetitive type manufacturing or discrete manufacturing, where you do have almost like a production forecast. We're going to build 10 of these each week for the next 6 months. So even if you don't have the sales order to offset the demand, you can put in a forecast. I want 10 of these, and you can have that sales order consume that forecast. So again, this is another way to get demand. It will allow you to create firm orders in MPS or MRP based on your production plan. If you're a government contractor, some folks can use this, some folks can't, but it is an option that if that fits your business model, it might be something you want to look at. Supply chain, challenges of procurement. So procurement is always a challenging thing. You know, do we have the right suppliers? Will they deliver on time? Will they deliver good quality? The other thing with procurement is if you are a government contractor, you probably need to make sure you can pass a CPSR audit. And so with that, you have to have very specific procurement processes. You may need 3 quotes for what you purchase. You may have sole source vendors. There's a wide variety of things that could happen in your procurement process that you have to follow to be compliant in this area. That makes procurement a little extra hard because, again, you've got to satisfy the requirements to be able to pass that particular kind of audit. The next question that might be asked is how are requisitions approved? Is there a min-max dollar level? Does it go through multiple approval options? But this is how the purchases basically are approved. Who's approving that it's okay to buy these items? And then finally, the last one on this section here is for invoice processing, working with accounts payable. Is your purchase order a 2-way match or a 3-way match? Do we need a receipt? Do we not need a receipt? The other piece of procurement, which it's a little offset of procurement, it's not really a piece of procurement particularly, but it's the receiving and quality control. If you're manufacturing and you have inventory, inventory is increased by receiving against your purchase orders. So this is area is very important. It needs to be very accurate because it is going to affect your inventory numbers. It's also going to affect what accounts payable pays for. So when you're looking at receiving, the folks in receiving actually handle most of the assets of your company coming in. And then do you have inspections with these? Are there quality requirements that you're going to need? When you look at this, you know, you may have procurement planning, you might have quoting, you may want to track vendor performance. With quoting, you've got quantity breakpoints, expiration dates. You may have subcontractor requirements. The purchase requisition itself is the automation of being able to create what you'd like for the purchasing department to buy for you and getting it approved. And this could be generated in many different ways. It can be a manually entered rec. It can be a requisition that is created from MRP. It could be created from a sales order. It could also be a reorder. You've reached safety stock levels in inventory. And you do have requisitions to buy the outside processing, the coating, the chromate, the things that need to go on your manufacturing order. And you have to have some sort of approval process and workflow of that process. If you have multiple approval levels that the requisition has to go through, you need to be able to notify people that, yes, the rec is now in your queue. Can you approve it? Or if they reject it, send the notification back that it's been rejected. When you look at purchasing, there's different types of purchase orders, and I've just put a few up here. But your standard purchase order, I need 10 boxes of staplers, and I need them by this date, and I want to order them from Staples. I could have a blanket order with releases. So I have an overall agreement with Staples to sell me office supplies. I could have a subcontractor. A subcontractor purchase order is where I'm actually buying services, and that may work with a subcontractor management module where you're managing subcontractors to work on your projects. Or it could be a customer or government furnished purchase order, which has no general ledger impact whatsoever, but allows you to receive and put this information into inventory as the parts come in. Again, the purchase orders will support accounts payable with either a two-way or three-way match, PO line, subcontractor management, and one of the big things is project commitments. If we're required to look at things from a project perspective, giving a project manager visibility into their total costs today and their revenues today and what they've committed to spend against either expense reports or purchase orders gives them a better view of their project. So not only can they plan ahead and be proactive at what's happening with their project, they will know how and be able to track how profitable they're going to be on their project. And then again, receiving an incoming inspection. Production, there's all kinds of things we need to know about production. We need to know which orders are late, which are on time. We need to know who is working on the order and what routing step it's on, so where in the process is it, how complete is it. Are we building the right product? Have the engineers rev the product up? Do we need to do a revision change? Do we need to build it as is and then rework the item? There's all kinds of questions, especially in an engineer-to-order environment, about the part number and the revision we're building. Are we ensuring quality in our products? Are we following any quality standards we need to follow? Are the products being inspected at the routing step levels? Did we follow the correct processes during manufacturing? If you're building something that is very sensitive or is maybe aircraft related, there's a whole series of quality and documentation you have to produce on how that item was manufactured. So anything that's aerospace and defense, a lot of times has to have this procedure. It'll have to have the bill of materials, the router, and then, you know, who actually did the manufacturing steps on that router. And then what about product traceability? A lot of times you're going to have to deliver what's called an as-built configuration. So on an as-built configuration, you know, before we talked about an bill of materials, we have an engineering BOM of how it's designed. We have a manufacturing BOM of how it's built or how it is to be built. And the product or as-built traceability is the as-built bill of material. How did we build it? And that may include what serial numbers and lot numbers were used in the manufacturing of that item. So when you look at production control, it could be manufacturing orders or work orders. You want to look for something that is by project because you are going to be manufacturing by project. It's going to have for us our inventory requirements and our shortages. It's also going to contain our routings for that particular manufacturing order. And with the routings, there's a routing traveler that normally goes along with the items. It will do our serial and lot tracking. What are the serial numbers of the components going into my item? And then when I relieve the order, what is the serial number of my end item? I want to see shop floor and quality visibility. I want to see what routing steps are completed, who completed them, and what quality steps have been completed, and were the parts accepted or rejected. And I may also be looking for integration with time and expense or a shop floor time product. And then finally, if you do have a manufacturing execution solution, you want to look for an integration with that so that it can actually keep track of your product genealogy or your traceability, and it can keep track of the routing steps and the sign-offs on those routing steps. So there's a lot of value related to that you may have to do. And again, the picture on the bottom here kind of takes a look at when you're looking at ERP, MES, and the shop floor of where things kind of fit within that. Again, the MES piece is going to give the technician the ability to see their drawings, be able to do any kind of data collections if they have to do calibrations or things like that, and they need to record that information. And they can record the serial numbers that went into a top-level serial number. Again, the next screen here, these are different manufacturing order types you're going to look for. You've got standard work orders. You may have rework orders, and rework orders are used if an item gets damaged, it needs to be reworked, or you're revving up a part. An engineering change got approved, you have the old rev in stock, you have to make a small change to make it up to the new rev. Also, customer repair orders. Most of the time, companies do have some customer repair orders that may come back in. And this may be something where the customer gives you their item back and they either ask you to repair it, refurbish it, or maybe up the rev on it. So there's different requirements for a customer repair order. If you're using MES, you may also want a discrepancy rework order, which is a discrepancy against an original order, an upgrade order, which is also upping the revisions, and you may even have a maintenance, repair, and overhaul type order. So these are three additional ones when you're using MES. Okay, project and manufacturing costs. So I always look at costing in manufacturing is very two-dimensional. You have the costs rolling through the project and the general ledger costing. And this is going to be all of the different costs rolling through. And these are going to be costing for raw materials, purchased parts, work in process, and finished goods. But then you also have the cost accounting piece. So even though you may have everything flowing to the project and you've got an overall cost of that project, you may still want the cost accounting piece, which basically is what did it cost to build a particular part number. So a lot of your drawings have many part numbers on it, and many of those are make items. From a cost accounting piece, we may want to drive into what it costs for each of these individual items. So when I say two-dimensional, it's kind of, you want to make sure your project is running smoothly. You want to make sure all the costs are being recorded on your project. But from a cost accounting perspective, you need to know how much that particular item costs. Now, when you look at these costs, there's 4 different types of direct costs that can be captured, and multiple different types of indirect costs. When I look at a direct cost, this is going to be raw materials, purchase parts. It could be the cost of a subassembly moving to a higher assembly. Any labor costs that it takes to actually manufacture the item. And then any subcontract or outside processing costs. Again, you're paying for them to coat the item, use yellow chromate on the item, cut the item for you, whatever that you're having the outside process done. All of these make up your direct costs when you look at a manufacturing order. On top of these costs, you normally have your indirect costs or your overhead. And these are going to include things like a rate for fringe benefits that's normally applied based on labor dollars. You can have a materials handling, which covers anyone who works in the warehouse, shipping and receiving. It could cover any of their expenses. And this could be applied either on materials cost or, again, on labor costs, depending on how you wanted to do it. And then kind of the third that I picked out here is manufacturing indirects. And this is going to be manufacturing overhead. I mean, you've got your warehouse rental space, your electric bill, you know, your water bill, anything that it costs to actually make those items that's not considered a direct cost. You can control these costs. Again, we mentioned earlier, ECNs. That's a really, especially in an engineer-to-order environment, is a real important way to control your costs. You have to analyze before an ECN is approved of what it's going to do to your project. Indirect labor. Oh, sorry. Oops. I knew I was going to do that one time. There we go. All right, indirect labor. On indirect labor, it could be, you know, again, it's the people in the warehouse. It could be anything that people standing around waiting for things, anything like that. Inventory shortages, again, that triggers waiting time, people not having what they need to do. Transportation, shipping charges, expediting charges. Scrap, rework, and obsolete parts. Anytime you have scrap or rework, it costs you more money to produce a part. Warranty repair costs. Anytime your item gets returned to you and you have to fix it, it costs you money. And then just sheer paper and storage. You store a lot of paper in a manufacturing process. Now, one of the big things, and my big proponent with cost accounting, is yesterday's data helps tomorrow's estimating. On this one, we don't want to reinvent the wheel anytime we design a new product. We want to be able to look at historical information related to bill of materials, manufacturing bill of materials, and our manufacturing orders. We need to look at any schedule or program information that we can potentially use for a new bid and proposal process. And then basically our technical data. Can we reuse any drawings? Can we take an existing bill of material and tweak it to a new part? Can we use any work instructions? I have one client that actually has template work instructions based on the type of item they manufacture. They don't vary a lot between the different cables that they make. And historical data is vital to winning new business, because not only do you want to win new business, but you want to be confident that you're going to be profitable in that new business that you win. Compliance. It's probably my favorite topic. No, not really. But compliance, when you're a government contractor, can come from all different kinds of directions. You can have different compliance based on DFARS, NASA, DCAA, U.S. Department of Defense, FAR. Plus, you have the standard things like Sarbanes-Oxley, GAAP, cost accounting standards that you have to follow. So when you look at all these different things, if you're an engineer-to-order project manufacturer for the government, you have a lot of different rules that you have to follow. With these rules, one of the things is looking at the materials management accounting system. This has what they call 10 key elements that they want you to be able to check off on any of your projects. And some of these are as easy as having set procedures and proving that you adhere to the procedures you've set. Others are having 98% accuracy in inventory, 98% accuracy in your bill of materials. You also may have to do things like explain your borrow paybacks when you transfer items from one project to the other. So it goes through a wide variety of these rules that they're actually pretty common sense rules that it wants you to apply to any time that you're actually doing inventory or accounting or inventory or project manufacturing. And finally, we get to customer satisfaction. Will we deliver on time is always a big question. Does the product meet the customer's expectations? You want to deliver an end item to your customer that meets the requirements that they had. Quality, you want to deliver a quality item. You want an item that doesn't get returned to you for customer repair or something your customer's not going to be happy with. Are we keeping our customers happy? And again, this is a really important question because whether our customers stay happy or not may lead to whether we can win more business from that customer. And that is kind of the big question here, will they order from us again? So when we look at our overall focus in a project manufacturing environment, these are kind of the key things that you want to make sure from a customer satisfaction. And naturally, for you, the other key thing is, are you profitable against your project? Because you can make your customer really happy, but you're not going to make yourselves happy if you're not profitable on your project. And with that, I'd like to open the floor up to any questions if you want to type them in your Skype. Okay, with that, we'll go ahead and end our presentation today. Again, I want to thank you so much for joining.